Okay, what we're going to look at with this sheet is the relationship between a central angle and the arc that it opens up to form. What I mean by that is, imagine one single slice of pizza. You with me? You have a single slice of pizza. We're going to talk about the angle that the pizza itself measures and the degrees in the crust of the pizza. You with me? Okay. A central angle is an angle with its vertex at the center of the circle, which means the two sides are radii. The sum of all central angles in a circle, meaning if you had an entire pizza sliced up and you measured the degrees in the corner of every slice, how many degrees would there be total? 360. So how many degrees is there total around the edge of a circle? 360. An example of a central angle in this picture is angle B, or you could call it angle ABC, or CBA. But you can't call it anything else, right? Tori, make sure you're writing this. Here's the new part. The degree of the arc formed by a central angle's endpoints is equal to the degree of the central angle. Please quit humming. So right here, this is 84 degrees from here to here, right? Okay, so look at the arc it opens up to and forms. Please quit humming.
How do you mean?
I'm not asking. This is also 84 degrees. Okay? The central angle equals its arc. They're equal. Right? I want you to think of it as a piece of cake. Here's why I say a piece of cake. I've been talking about pizza this whole time. Now we're going to talk about a cake. Imagine a big round birthday cake. Traditionally, you cut a slice of cake. Traditionally, you tend to cut it in that triangular form, right? Okay, so you can imagine looking down on the cake after a slice has been cut and removed. You with me? When I say piece of cake, I'm implying that it's easy. You know, if you ever heard that expression, it's a euphemism or a metaphor, like, how was that test? It's a piece of cake. That makes it sound like it was easy. How many degrees are in the arc? Well, if I cut it like I would a circular cake, if I cut it like I would a cake, it's a piece of cake, which means they're equal. Right? Now, so right here, this little M stands for the word measure. This means the measure of arc A to C, and it would be 86 degrees. Oh, 4. Sorry. I didn't mean to do 6. 84 degrees. Now, I need you to focus your attention on the entire circle itself. If arc AC is 84, do I have enough info to find arc ADC?
Yes.
How would I find it?
Subtract 84 from 360.
You have the entire circle at 360. You take off the 84, and you'd be left with the 276 that goes here. And I want you to make a note where it comes from. All right, now we're going to dive into practice examples, okay? They start out very simple, then they get a little bit more challenging, then they get little bit more challenging, okay? All right, look at number 1. You're really going to have to watch. You can't, like, look away up here because I'm writing or pointing, and it's going to help you to come up with the answer until you start to get used to this on your own. So look at number 1. We have a series of things we need to find. When you have problems like this, it's a lot easier to just go to the picture and label everything instead of coming over here and finding each individual thing. That takes longer. So ignore the questions, go to the picture. Let's label everything we can, okay? And it all stems from the one given, 21 degrees. All right, so that 21 degrees is referring to right here, correct? Okay, tell me what you could label from it. What else do I know?
Measure JK.
I know the measure of arc JK would be what?
21.
Also 21, because that was a central angle.
The arc measure in L is
Why?
vertical angles.
There you go. You got to use vertical angles from months ago. Anytime you have two straight lines crossing, you have vertical angles. Okay, what are the two straight lines in this picture?
KM and JL.
And they are what type of lines in the picture? Vocab word.
Alternate.
They are two diameters. Notice you have two diameters here. Diameters are very helpful. One diameter is helpful. Two is even more helpful. So right here where that's 21, this would be 2. I'm just going to put the arc since I can't label it without taking up too much room. And then arc ML is 21. Now here's where I need you to look, watch, because after I ask the question, I'm going to remove my marks because it gets crowded. Here's what makes circles difficult for people. You've got to learn to mute some of the info, mute it, mentally mute it, in order to be a problem solver with the picture, okay? So what I mean by muting, I mean focus your eyes on just one diameter, just one. Don't worry about the other one. So that one diameter right there, yeah, would mean this is a, what? Semicircle. And if you have a semicircle, you have a secret number attached to that. What is it? 180. So if this is 180, if this is 180, and that little chunk is 21, do I know what this remaining piece is? How do I find it?
180 subtract 2.
So 42.
21.
180 minus 21 would give me this right here. And what is that?
I'm going to stop speaking.
Well, y'all are supposed to have a calculator.
I got my calculator out.
It's 159. If that's 159, look at the picture, then what is
Vertical
this
angles.
angle right here that it comes, that, like, imagine the piece of cake. That'd be a really big piece of cake. But if that's 159, then this angle right here would measure what? 159. And it's vertical to this one over here, which would measure 159.
And then the arc
And
is
then the arc
159.
behind it would measure 159. And now, what you've just done is you've just filled in the entire picture with everything. So now you just look at the question and you answer it based on the picture. So the first question says, what's the measure of arc JK? Well, we already found that. We labeled it. It's 21. Next question says, what's the measure of angle JNM? JNM, we already found. It's 159. Next one says, what's the measure of arc KL? next one says, what's the measure of arc JKM? Alright, this is the first time we've had to do this, so let me highlight it. Watch.
Hold on, I got it.
JKM.
201.
Two ways to get it. Look at this. This is where, once again, this is where this is the most challenging unit, because there are going to be, from here on out, pretty much every single question has multiple ways to get the right answer, and we don't have time to go over every right way. I need you to just start seeing it one of the right ways and running with it, okay? So the first right way, it's a tongue twister, the first correct way to get this is by simply adding up the pieces along the way, right? So 21 plus 159 plus 21.
180. Well, that's 101.
No, 201. Second way to get it. 201 is the right answer. Here's an alternative way to get it. Please watch, because it may help you in a future problem. Alternative way to get it. When I highlighted it, I noticed that it was the entire circle except for one big arc, right? The only part I never highlighted was the 159. So a second way to get it is,
Subtract 150.
there you go, 360 minus 159. So 360 minus 159 will still give you 201. There is a third way. Y'all ready? Look at this. This is where your mind is going to start to become a problem, like a puzzle solver. The third option, stay with me y'all, is to notice that from M to K is what? It's a semicircle which measures 180.
80.
So a third way is to say, well, that was 180, and just add that to 21, and you still get 201. So look how long it took me to go over all three ways for that one simple problem. Now you can see why we don't have time to go over every single way on all these problems. You also can see now why this is a difficult unit, because you may go one way, your neighbor may go a different way, you may get the same answer, but if you're looking at your neighbor's work, you may be like, I don't understand why we went different routes. It doesn't mean that you're wrong. It means that y'all just saw it in a different light, okay? So this is 201. Right?
Yeah.
You with me?
Yeah. I don't know what he's doing.
Where's your worksheet? Okay, just checking. MKL. Right? MKL. So M to K to L, but you don't need to pass through L first, right?
Right.
So that would be M, K, L. The fastest way to get this would be what?
Whole circle equals 360 and subtract 20.
Take the whole circle, 360, subtract off the little chunk that is not covered, and you get 339. All right, let's look at number 2. Let me show you a common mistake I've seen people make. Red means wrong here. I've seen people assume that any two lines make a diameter, and that's not the case. If you look up here where I have highlighted in red, I've seen people put together two radii and say, oh, that's a diameter. Well, clearly that's not a diameter because it's curving, right? Or it's crooked, I guess you could say. You need to make sure that you are correctly identifying diameters. There's one, and there's one. So you do have two diameters here. Take a second, try that one. Always start with what you know. Always go to what you know. For instance, I know this is 87 right here, which means this is 87 here. I know this is 72, come inside, so this is 72. The next approach is going to involve those diameters. Diameters cut the circle in half, leaving it to measure 180. So we can go to the side we know more about. Look at this. I don't want to go this way, right? Because I don't know anything yet down here. So go to the side you know more about. Here's the diameter. There's a semicircle. I know 72 and 87, so I have enough to find arc ST. 180 minus 72 minus 87 will leave me with arc ST. Did you get 21? Now you might be wondering how are we going to get to the other side? Multiple ways. Find another diameter. Here's this diameter, which means this is 180. One chunk of it is 72. So the other piece would be what? If this is 72 from S to W, then what's W to V? Thank you, 108. So the diameter.
Please excuse the interruption. I have some names to call and everyone needs to listen.
Filling in the picture, here's a diameter, which means this is what? Diameters create semicircles, which measure 180. So, and this piece is 108, so this would be 72. Or you have the vertical angles. Alright, so what's the measure of angle UXV?
72.
72. What's the measure of arc ST?
21.
What's the measure of arc WV?
Wait.
What's the measure of arc TW?
93.
You would do from T to W, 21 plus 72.
93.
Now we're going to go from T to V to W. T in the direction of V, then land on W.
267.
Yes.
How?
I didn't think I was gonna get this until
Wait, back up. How?
What? How what?
We go from T to V to W, right?
Yes.
No.
The measure, sir.
Hero. Hey.
Everybody.
Alright. Number 3 is looking to see if you remember what the little rectangle or square notation means. It means 90. It's also teaching you that sometimes you might have a pair of vertical angles where one of them has actually been split up. And here's what I mean by that. You see how this is a diameter here? Okay, and then you see how that's a diameter there? Okay, so you have this 90-degree angle here, and it would be vertical of this over here together would have to measure 90. So if this is 34, I can find this by doing 90 minus 34. So that's the point of this question.
Who's that? Don't let it. Is that me?
So this is 90, so this is 90 over here together total, right? Which means that 90 minus 34 is 56.
Would all the sides equal to 90
Yeah,
all around?
yeah.
Yeah, because you do have the diameter. You've got the diameter here, which means this is 180.
Oh, yeah.
180 minus 56 minus 34 leaves you with 90 here, and then 90 here. You should get 90, 124, 236, and 304. Yep.
Yeah.
Why does this seem like easier than
Because I taught it really well.
You're giving
And you listen. Yeah. Nope. Just kidding.
very cocky.
I'm just kidding. What's your question? Which one? Right, that's how you set it up. You gotta set it up.
No.
You do software X first.
Like our
Alright, look at number 4. Please try it. You try it right now.
Oh.
Now this total over here is 90. This is 19 right here, so what's RTS?
This is 90, this is 90, this is 19.
You do have 2 diameters in here. The 2 diameters will create vertical angles. The 2 diameters will create vertical angles, and vertical angles are congruent, so there's more 19-degree angle. There's another 19-degree angle in here, and a 19-degree arc. Then you've got your diameter, which is 180, minus the 19, right? Right here. Alright, don't look up here until you're done.
How do we know what direction to go with this?
Hey, Jackson.
You want to part with you?
I may need to post. I will post, y'all, I'll post it. A couple of them are a little hard to read. I'll post it so that, yeah, I shrunk it down, trying not to use too much paper, but I guess it's not a good idea, because it's not hard to
Clockwise?
see.
This whole.
I'd like it to be done before class. How many is it? It's only 9 questions, and you would, at the beginning of class, you would check with your partner. So you would allow us to get more done and have more free time if you have it done before you get here.
I
How
got
do we,
the
how do we know which way to go? Clockwise?
It doesn't matter, it depends on the letters.
Yeah, well, it says PS.
But
So it
it's
could
only
go this
two,
way
it's
or
only
the
2 letters, which means go the short route. We talked about that yesterday. 2 letters means minor, 3 letters means major.
Yeah.
Okay, the leveled up aspect here is now, instead of it being just plain numbers, we have polynomial expressions. It's not that bad. Go and find the actual numerical value, then set it equal to the polynomial. So for instance, number 5. First of all, we have how many diameters in the picture? 2. We only need 1 of them. We have 2. We only need 1. I would focus on the one that when you draw your semicircle, that you know all of the pieces. For instance, R, T. When I draw my semicircle, I know 15x minus 26 is the big chunk, and I know 26 is the little chunk. What do I know is in that measure?
180.
Okay, so what does 15x minus 26 and 26 have to do? Add to equal 180. And that's where you get your equation. They add together to form a semicircle. That means they add to equal 180. So let's solve that. The 26 cancels. 15x equals 180. Divided by 15.
12.
You get 12. Let's look at number 6.
Wait, is that all I have to do is find X on this?
Well, it says
Put on third.
number 6.
Something.
Find the arc that has the expression and say to yourself, okay, I need to know how many degrees are right here. And then look at your clues. Your first clue, you have 2 diameters here, but the only one that's helpful at first is this one. Why?
Because on the other side, it shows what that equals as a whole in that one area on the other side.
Yes. So this is 103, which means I could find HG. 180, right? Semicircle. Minus 103 is what? 180 minus 103. 77, right?
Yeah.
Okay. Here's another diameter. What does this measure? 180. Now I want you to start using the technique. I've talked about it before when we were dealing with the angles of a triangle. We use the technique of subtracting off what you already know. This has to add to 180. What do I already know?
77.
And
15.
so if I do 180 minus 77 minus 15, I don't want to interrupt.
We'll double up on 35. That's 140 will be 71. That's 87 will be 140. Your best changes for today. That's 114 and 16 will double up on 35. That's 140 will be 71. That's 87 will be 140. Please remember to turn in your paper.
Great day.
Oh